Okay, so in this video we are going to be seeing how we can apply those concepts of the perimeter ratio, the area ratio, and the volume ratio. Okay, so a question has been given to say, given that the volume ratio of two similar shapes, okay, given that the volume ratio of two similar shapes is 64 to 27. So what we have been given here is the volume ratio. Put that in mind. So given that the volume ratio of two similar shapes is 64 to 27, calculate, number one, the volume of the smaller shape if the bigger shape has a volume of 80 centimeters cubed. So this problem, the first problem is regarding volume. So we are going to use the volume ratio directly. We won't convert the volume ratio into the area ratio or into the perimeter ratio, anything like that. No, because this question is strictly involving volume. We're just going to use the volume ratio as it is without making any conversions. Okay, without making any conversions. So let's see how we're going to handle it. So your volume ratio has been given to be 64 to 27. Okay, 64 to 27. Just by looking at it, I'm sure there is no number that can go into 64 and 27 without leaving a remainder. So let it just be like that. So the 64 is definitely representing the big shape. The 27 here is definitely representing the small shape. Let me say small shape. Okay, so this is how it's now going to be. You're going to say 64 to 27. The volume that has been given here is the volume of the big one. That's saying the volume of the smaller shape if the bigger shape has a volume of 80. So on this big side, you're just going to put 80 here. You're trying to calculate the volume of the smaller one, so let it just be x. You don't know what the value is, so let it just be x. Definitely here, what we can do is that we can cross multiply. Okay, we can cross multiply, and this is just going to be 64 times x, which is just going to be 64x. And then this is going to be 27 multiplied by 80. 27 times 80. 27 by 80, if we punch this on our calculator, 27 by 80, the answer is going to be 2160. 2160. So we're going to have 64x is equal to 2160. We can now divide both sides by 64, even here by 64, and therefore your x value will be equal to, so what we're now going to do, we're just going to say 2160 divided by 64. The answer is going to be 33.75. 33.75 centimeters cubic or cubed. So this is going to be the volume of the small shape. This is going to be the small volume. The volume of the small shape. That's just going to be 33.75 centimeters cubed. This is 80 centimeters cubed. The next problem, they want us to find the area of the bigger shape if the small area is 15 centimeters squared. So this second question is involving us to determine the area. We can't use the volume ratio directly. So what I'm going to do is that I'm going to use the area ratio. So I need to derive my area ratio from the volume ratio. Now, if you recall, your perimeter ratio is just going to be equal to the cube root of the volume ratio. And I had also given you to say that your area ratio is just your perimeter ratio squared. So what you can do here is that if you want, you can combine these two formulas together if you want to, or if you want, you can be going step by step. If I combine both of these formulas together, remember I'm trying to determine my area ratio, right? So think of this to be equation 1, this one to be equation 2. If I get this and then I substitute it here, what I'm going to have is this. I'm going to have area ratio will just be the cube root of the volume ratio, but remember there is a squared outside. If you want, you can go in this way. It's certainly going to work. Okay, it is certainly going to work. But if you see that maybe this can be hard for you to recall, you can just be going step by step. You determine your perimeter ratio and then you also determine your area ratio. It's up to you. So let's first find our perimeter ratio. Remember, our perimeter ratio is just the cube root of the volume ratio. And the volume ratio that we have been given here is 64 to 27. The cube root of 64 is going to be 4, because 4 times 4 times 4 is going to give you 64 if you multiply 4 3 times by itself. The cube root of 27 is going to be 3. So that's going to be a perimeter ratio. And then you are now going to convert this perimeter ratio into your area ratio like I had shown you. So this is now just going to be area ratio. Remember, we said that this is perimeter ratio squared, right? And your perimeter ratio is just 4 to 3. So this is just going to be 4 to 3 squared. So your area ratio is just going to be 4 squared, the answer is going to be 16. 3 squared, the answer is just going to be 9. That's going to be your area ratio. So this is the value that you're now going to use. This is the ratio now that you're going to use to determine your area. If we never had this, if we never determined this, everything that we would have done would have been in vain. So our area ratio is 16 to 9. So like we did it here, we're just going to say 16 to 9. 16 is representing the big, the 9 is representing the small. The value that we have been given here is the small area, which is 15. So you don't know the big one, so it's just going to be x. Here it's 15. So what is now going to happen here is that when we reach at this stage, definitely there will be a cross multiplication. So 9 times x, this is just going to be 9x, right? And then 16 times 15, okay? 16 times 15, the answer is simply going to be 240. Okay, this is going to be 240. And then from there, we're going to divide both sides by 9. And therefore, your x value is going to be 240 divided by 9. The answer is going to be 26.67. Round it off to 2 decimal places. 26.67 centimeters squared, because this is the area. So it's supposed to be in centimeters squared, centimeters squared, centimeters squared. If it was meters, meters squared, kilometers, kilometers squared, just like that. So you can choose to answer them individually. You first determine your perimeter ratio, then you determine your area ratio, or if you want, you can just use this combined equation. That is, area ratio is equal to cube root of the volume ratio squared. And this can also be done for the volume ratio as well. If you were given the volume ratio, or rather if you were given the area ratio, and then they wanted you to determine the volume ratio, did you see the way you did it? You just interchange these values. Okay, you just interchange these values. So if it was for the volume ratio, you would have just said this would have been the square root of the area ratio, and this is going to be the power 3. So this is how they go. So area ratio, it's cube root of volume ratio squared. If you bring out the volume ratio, taking the area ratio inside, the two numbers will interchange. The 3 is going to come outside, the 2 is going to come inside. And this is what you're going to have. So even though we haven't shown it, there is a 2 that is just exactly right here. So bear this formula in mind as well. It's very important. So that's it for this problem. And then lastly, they're saying find the length of the big shape if the small shape has a length of 5 centimeters. There isn't like centimeters squared, centimeters cubed. This is just like centimeters to the power 1, to the degree 1. So this is strictly pointing out to the perimeter ratio. And the perimeter ratio is something that you had already found. Your perimeter ratio, it's something that you had already found. We had found our perimeter ratio to be equal to 4 to 3, remember? So 4 to 3. Again, the 4 is representing the big shape, the 3 is representing the small shape. So this is just going to be like 4 to 3. Right? 4 to 3. And then, what have we been given? Yeah. The small shape has a length of 5 centimeters. So you're just going to put 5 centimeters here. X. Cross multiply, you're going to have 3x, right? 4 multiplied by 5, then it's just going to be 20. So what you're going to do is that you're just going to divide both sides by 3. Just going to divide both sides by 3, and if you divide both sides by 3, that is 20 divided by 3, okay? 20 divided by 3, this is going to come out as 6.67. 6.67 centimeters. Don't put squared, cubed, centimeters, because this is just like length. So it's referring to the perimeter ratio here. So this is how you can determine this using your perimeter ratio, volume ratio, and area ratio. You normally don't need to use specific formulas here. Besides, they even generalized it. They was just like the area of a bigger shape. Shapes are in different sizes, in different types. We can have a cylinder, we can have a cone, we can have a pyramid, we can even have a frustum. So this is just how we handle these things generally without using some specific formulas. So I hope this really helps for your revisions.